Okay, so in today's video, we'll be trying to imagine any quadratic equation can be represented as the equation of a parabola. Now, we know that the basic equation of a parabola can be of two types. One is I can write it as y minus beta whole square. This looks like a 4. Let me make that y. So y minus beta whole square equal to 4a times x minus alpha. So in that case, based on the value of a, whether it is positive or negative, my graph for the parabola can look either like this or like this. This is for this form, for y minus beta whole square equal to 4a times x minus alpha, and we know that the vertex of the parabola will be at alpha comma beta. That is when the power where y is raised to the power 2. This is one form of the parabola. The other standard form of the parabola is the reverse. So it's x minus alpha raised to the power 2, that is x minus alpha whole square, equal to 4a times y minus beta. So this is the reverse, where x is raised to the power 2 and y is just raised to the power 1. So this sort of parabola, it either looks like this or it looks like this, based on the value of a, whether a is positive or negative. In this case, a is positive, and in this case, a is negative. Now, what is our objective? In today's video, our objective is to represent any standard quadratic function. So let me take the most standard quadratic function that I can think of. What is it? Y equal to a x square plus bx plus c. This is the most standard form of a quadratic equation, the most general form of a quadratic equation. This a and this a have nothing in common. So let me just, for the time being, remove this a. Or what I can do is I can just put some other letter here. Let me put some 4g and put this 4g, so that this a and this a is not confused. Now I have this standard equation of a quadratic equation, standard form or general form of a quadratic equation. I want to express this as a parabola. Note that in this equation y is raised to the power 2, whereas in this equation x is raised to the power 2. Now, in the functional form of a quadratic, this functional quadratic form that I have x raised to the power 2, which means I cannot convert it to this function. So this form of parabola is out of the question, which means I have to convert the parabola that I have, the quadratic equation that I have, into this form, such that x is raised to the power 2. You see, x is raised to the power 2 in this expression, and x is also raised to the power 2 in this expression. So I have to convert this expression, I have to convert this equation into this form, x minus alpha whole square equal to 4g times y minus beta. Now, how can I do that? What I can do is, let me rearrange, or let me just take something common, so that I can get x alone. I can remove all the other coefficients. So what I'll be doing is, I'll be taking a common. Now what does that leave me with? X square is left alone. However, there's the coefficient of x now becomes b by a, because there's an a outside the bracket, so the coefficient of x becomes b by a. So I have b by a times x plus c, so a is out there outside the bracket, so I have c by a as the constant term here. Now what I want to do is, this is x minus a whole square form, so x minus alpha whole square form. So I want to express this in the same form, which means I want to bring an x plus alpha whole square format. So x minus alpha whole square is x square minus 2x alpha plus alpha square. So I want to bring it into that form, which means I keep a as before outside, I put x square, and then what I do is I want to bring in some 2 something into x term, so that I can make it a square form. Now I have b by a as the coefficient of x here, and I want this to be the coefficient of x as well. So I want to convert this b by a into 2 times something. The easiest conversion will be to take b by 2a inside the bracket, right? So 2 and 2 gets cancelled and I'm left with b by a. This term over here gets converted to this term. So if I just take some other color, this term over here gets converted to this term over here, right? So I have just rearranged or readjusted the look of the expression over here, but the expression itself remains the same. So this is one part of the expression done. Now I need to adjust it to make it of this form. So I have to make it in this form, so I have to adjust it. X square plus 2, a constant x. So what I need is the square of this term. So if I want to have, let me just take it as blue. So if I want to have the square of this term, that will give me b square by 2a whole square. 2a whole square is actually 4a square. Now what happens is this term is not there in the expression, right? The above term, it has just a c by a, it does not have b square by 4a square. So in order to maintain this equality, what I do is I remove, or I again deduct the additional term that I had brought in, 4a square, right? So now I have this form which I can convert. So I can rewrite this as a, then I write it as x plus b by 2a whole square, right? And then what I do is I multiply a with these two expressions. So a and a gets cancelled, and what I'm left with is c, or what I can do is, let me just keep a minus over here, because at the end I'll have to bring it to the other side, to the side where there's y. So what I do is I take minus common and I multiply this expression. If I talk about this expression, then I multiply a with this expression and I'm left with b square by 4a, because there was already in 4a square. When I multiply it with a on this side, so it becomes 4a. Since there was a minus, so I wrote this in front, and then there's a minus over here because c by a was preceded by a positive sign. So when I take a minus common, there's a negative sign before that. So this is the expression that I get, right? Oh, sorry, the a won't be there because I have already taken a common. So I'm left with this expression, just c, right? Now, what I can do is I can take back this expression to the other side. So I push this expression to this side. So what I'm left with is y plus, because this minus goes over to the other direction, to the other side. So I have plus this expression. This expression can be rewritten as b square minus 4ac. If it looks familiar, that's nice, because it's actually the expression for the discriminant of a quadratic equation, basically the discriminant part of the Sridharacharya's formula. So I get 4a in the denominator, and this is this portion, and on the other side I have a into x plus b by 2a whole square. So if I compare this expression, if I want to highlight this expression, so if I want to highlight this expression and if I want to compare it with this expression, I see that in this case alpha, rather alpha is actually this expression. This expression is alpha. So I take a different color. This expression is actually alpha, and this expression b square minus 4ac by 2a is actually beta. So we know the directrix of this, the vertex of this parabola is actually, now note that in the original equation that we were comparing it with, the sign preceding alpha and beta as well were minus, but in our expression, derived from the standard quadratic equation, we have positive. So actually this is minus beta, minus alpha, and minus beta. So actually the vertex of this quadratic equation is minus b by 2a, that's the x coordinate, and this is minus b square minus 4ac by 4a. So that's the vertex of this quadratic equation. So what we can say is any quadratic equation of this form, because you can express any quadratic equation in this form, just put some values. What you need to note is, for this to be a quadratic equation, a cannot be equal to 0, right? If a is 0, then it is no more a quadratic equation, it becomes a linear equation, because x is to the power 1, because this term disappears. If a is 0, then this term disappears, so it does not, it ceases to be a quadratic equation essentially. So what happens is there's this restriction on a cannot be 0. Other than that, you can have any value of a, b and c, and you can actually write any quadratic equation in this form given some values of a, b and c. So if I give you any quadratic equation, you'll be able to express it in this form with some values of a, b and c, which means I have actually rearranged this equation to this form. So any quadratic equation can be expressed in this form, which, and this is actually the general form of parabola, which kind of looks like this or this, again based on the sign of g here. Now that I've changed this, so it essentially depends on this quantity, this a quantity over here, based on the sign of a. So what happens is, in this case, a is greater than 0, and if it faces the opposite direction, then a is less than 0. So based on this, we have the different shapes of the parabola, but other than that, any quadratic equation can hence be represented as a parabola, and the perfect look of it depends on the value of a, whether it faces up or down, and the vertex is represented by this point. So minus b by 2a and minus b square minus 4ac by 4a.